After understanding a single Turing machine, how do we categorize the millions of different problems they can solve? We do it by grouping them. Problems like searching, sorting, or solving puzzles each require a certain amount of computational resources. We sort these problems into what we call complexity classes based on the primary resource they consume. First, we can classify problems by time. The Class D time contains all problems that can be solved within a specific number of steps, determined by a function of the input size, n. As the size of the problem grows, the time required increases. This formula tells us precisely how quickly that cost grows. Similarly, we can classify problems by the amount of memory or space they need. This is the class D space. As the input gets larger, the machine must use more of its tape to store information and find the solution. From these basic ideas, we get one of the most important complexity classes, P. This is the class of all problems solvable in polynomial time. Polynomial growth, like n squared or n cubed, is considered predictable and manageable. We often call these the efficiently solvable or easy problems. But what happens when the growth is not so tame? This brings us to the class EXP for exponential time. Let's compare. For a small input, the values seem similar, but watch how quickly the exponential column 2 to the n pulls away. The growth is explosive. This is the hallmark of hard problems. The time required becomes unimaginably large, even for moderately sized inputs, making them practically unsolvable at a certain scale. Understanding this vast difference between P and EXP is fundamental to mapping the landscape of computation.